Hi all, welcome to the new episode of Tech Insert. This is an emergency table lamp which I got from a scrap shop. The look and feel of this table lamp is so excellent, and that is why I took this from the scrap shop, and I feel that I can make it back to life. This is a foldable one, and you can see how much compact this is. We can extend this to pretty nice height, and this is also looking very good. You can see a 230 volt power input for charging, and I do not have this cable with me. Some details are written in its backside. You can read it, right? This has 3 foldable notch which is having adjustable plastic screws. First we will check the LEDs are working fine or not. We will deassemble the LED panel now. This is having 31 SMD LEDs. Roughly we can tell that 31 into 0.1 watt, that is 3.1 watts. Normally SMD LEDs are 0.5 watts, but this one is having only 0.1 watt. We can check the LEDs using multimeter in diode mode. All LEDs are lighting, right? I think they have given parallel connection to all LEDs. I feel multimeter do not have enough power to light all LEDs, and that is why all LEDs are lighting very faded. We can test this using a 9 volt battery. First I will connect the 9 volt battery with an 1K resistor in series, and let's see what will happen. I will connect a 9 volt battery connector and will test it. But see, it is not lighting, right? I will try once again and will try it without resistor. Here also, yeah, it is working. Be some corrosion in the soldering point. I can see one LED is gone. The 9 volt battery is an old one and it has a voltage of less than 6 volt only. That is why the LEDs are not blown off. You can see one LED is gone. We can first replace that LED with that new one. The one we have used is a 0.5 watt LED. So when comparing the brightness with the others, this is having a bit less one. But this is also fine, right? This is most probably a 4.5 volt battery, and for charging this is using a transformerless power supply. This type of power supply I have made a video on that, and the link will be given in the description box. What we will do is we will dismantle everything inside this and we will install a lithium ion battery inside this. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. Now we will find out how much current this LED panel will take. We will use my bench power supply and make the voltage as low as possible and slowly increase the voltage and fix the voltage to full brightness of LED, and thus we will get the current and voltage. You can see at 5 volt this is taking 2.2 ampere, which is very high. I will slowly reduce the voltage to 4.5 and see how much current it will take. At 4.5 volt the current using is 1.8 ampere, and by reducing the voltage to 4.5 the LED brightness is same, so we will again reduce the voltage. So we can fix the current to 1.2 ampere. This is the complete wiring diagram we will be using here. We will take two lithium-ion batteries and use in parallel. We will fix this inside this battery holder and remove this series connection and parallel connect, so that the voltage will be same and the current will be doubled, thus increasing the backup time. For charging each battery, we will use separate BMS. This is because one battery is 3000 mAh and the other is 2500 mA. If we are using one BMS for charging both, then that will be a problem. That is why we are using separate BMS. And now the battery is 3.7 volt. We need to raise it to 4.5 volt. For that, we will be using a booster module. We will remove all components in this PCB and will use this PCB for fixing our BMS. At 1.2 ampere, the booster module is getting very hot. Even though in description it is written as 2 ampere maximum, it will not survive more than 1.2 ampere. So we will use a current limiting resistor in series with the LED. This is 0.39 ohm and this is 1.2 ohm. This we took from the same old board. They are also using the same series resistor for the LED panels. Let's fix this and check how much current the LED panel will take. You can see it is taking only 0.6 ampere, that is 600 milliampere, and now the booster module is not that much hot. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. The resistors are very slight warm and this will not have any issues on that. We will connect a power bank and test whether it will charge or not. If you have any suggestions, please comment on this video so that we will know that. If you like our video, please click like button. If you do not like our video, click dislike button. If you haven't subscribed to our channel yet, please click subscribe button. Press the bell icon so that you will get the notification whenever we upload a new video. This is Tech Insert signing off. See you in another video. Till then, goodbye and please take care.